everyone, my name is Tenzin Kyosang and I'm from TCV School. I read in class 10. So today on behalf of my team, I'm going to present our science project. The title of our science project is Eco-Friendly Digital Microscope. The reason why I call this eco-friendly is because we have reused plastic from domestic waste to make this digital microscope. And it comes under the sub-theme Life, Lifestyle for Environment. This year our school has bought a good digital microscope, but at a staggering price of 92,500 rupees. So we thought of building one after knowing its components and understanding its functioning. We aim to deliver such a microscope at a very low cost, less than 1,000 rupees, made from domestic waste to every school and inspire other students to work on it and acquire their own. As you can see, this is how our digital microscope looks like. First, we have our main body, which is made from used plastic liquid detergent container. And then we have this coarse adjustment, as you can see. And right below the coarse adjustment, we have our fine adjustment here. And the optical device in this digital microscope is this camera. And if you want to make it cheaper or reduce the cost of it, then you can use an old camera from an old used phone. And then we have an eyepiece. It is of 10x magnification. And then we have the objective lens. Let me flip. Yes. This objective lens is of 40x magnification. You can use a 10x magnification if you want, but here we have used 40x magnification. And then we have the stage and the slide. And then we have the source of light, which is the miniature LED bulb. Here, miniature LED bulb. And this scientific principle involved in this digital microscope is the use of optics and digital camera to output the captured images on a computer screen or on a projector. This digital microscope captures images and views of the images, which is useful for image analysis and sharing. A microscope works on the principle of refraction of light using convex lens, which focuses light. Here we have used the eyepiece and the objective lens. First, the objective lens will form an image which is larger than the object. Here we have used 40x magnification for that purpose. And after that, the image so obtained will act as an object for the eyepiece. Then finally, the eyepiece will form the final image, which is further magnified. Our project enhances creativity and engineering skills among students, also promoting STEM education. It will provide an efficient tool to inspect and analyze particular things for research. Not only that, students can also conduct their academic experiment independently. Last but not the least, I would like to share some images that we were able to capture from this digital microscope. First is the image of a plant cell. Second is the image of a stomata. And third is the image of a xylem tissue. Thank you.